Hello everyone, I am Harsha Bhagawaty. I am a graduate student here at LSU. I am working in work package 2 of CyberTools under Dr. Gabriel Allen and Dr. Nathan Brenner. I am working on storm surge prediction tools. As we all know, hurricane prediction is important for Louisiana and Gulf of Mexico in general because of the damage that hurricanes have caused in the past, like Hurricane Gustav and Hurricane Katrina. So it can be good if we can predict the after effects of hurricane beforehand, and preventive measures can be taken. One such tool which is being used is CIRC, which is the advanced circulation model to predict the effects of hurricanes, and it is used by the Hurricane Center here at LSU. What we are trying to do is we are trying to compile a hurricane archive where we simulate the major hurricanes which have occurred in the last 50 years. CIRC uses unstructured mesh to as its input. This is an example of an unstructured mesh which represents southern Louisiana, and like for each square mile of area there is a grid point. And once the CIRC simulation is complete, it can predict the height of storm surge and wind velocity at each point based on the input files given to it. Now we will look at what the CIRC inputs are. It has the grid file which represents a particular geographical location, and the model parameter file. In that we define what outputs we need, like for example say pressure, wind velocity, storm surge, so on and so forth, and how often we want to print out the input, say every 30 minutes or every 1 hour. And 4.22, this is the most important file. It takes in the wind velocity data, like we get this from the National Hurricane Center, and it predicts the location of hurricane in time. And 4.13, it specifies the boundary conditions for the mesh. Well, CIRC can produce a lot of outputs, but we are more interested in finding out the elevation at each grid point as well as the wind velocity. And we also take in atmospheric pressure as outputs. To run CIRC, we do a ADC prep, in which we specify the number of processors we want to do the run on, and then we will be using pHydZirc, which is the parallel version of CIRC code that is which runs on the cluster. And once the run is complete, we will be doing a post processing of this. For this workflow of building a hurricane archive, these are the steps which we will be following. First, we will be compiling a list of major hurricanes which have occurred in the last 50 years. Then we convert that into CIRC format and then do some test runs as well by varying the input parameters. And then we will be post processing the CIRC output to produce our required output files such as for storm surge and wind velocity. And then we will archive the data on PetaShare, which is a storage archive. And then we will be doing neural network analysis based on the already done runs by downloading the data on PetaShare. Currently I am working on executing this workflow wherein we can automate the process of doing the simulations, archiving the data on PetaShare, and for people to download data from PetaShare. We'll also be doing the runs by varying these parameters for each hurricane. Their central pressure, we'll be varying them about 10 or 20 millibars, the maximum radius of the hurricane, the forward speed of the hurricane, and mean angle of the hurricane. Like we vary the angle by taking two tracks, 15 degrees to the right and 15 degrees to the left of the actual hurricane. Coming to the PetaShare metadata tags, there are like two tags, science data and system data. Like these tags help us retrieve the data in an easier manner from PetaShare because this archive is several terabytes in size, and we can query the data and retrieve the data. This is the metadata which for each storm which we store on PetaShare. They are like storm name, year, the model type, track, the official advisory number of the hurricane, and the maximum values of storm surge and wind speed. These are the system tags from a computer science perspective, wherein we look for machine name, user name, the simulation start and end dates, wherein the user can, if he wants to do a rerun, he can check for when the last simulation was run, so on and so forth. All in all, we hope to build a successful hurricane archive wherein users can get the data they want, and data can be used for neural network analysis to predict the after effects of hurricane in an effective manner. Thanks.